Hey, what's up? It's your old pal, Mr. Cook. We're working on this AP Calculus AB Unit 5 review. We just got through the first 3 pages, which is the first like 10 problems. And now we're working on the last two, so number 11 and number 12. Let's see what we have for us. So number 11 says solve the differential equation. So we got dy dx is equal to 5 cosine x given this initial condition. Okay, so this one is actually quite a bit like a problem that we had earlier, I think, right? Wasn't there another one we had to solve for an initial, for a particular solution? Yeah, like number 4 and also number 3. So this is just, it looks like this test is definitely going to have one of these kind of problems. So please make sure that you know how to solve a differential equation and find the initial condition from that general solution that you get from the differential equation. All that stuff that I just said, it's actually really easy. All you got to do is just take the differential equation and then take the antiderivative, basically. So if we've got dy dx is equal to 5 times the cosine of x, we can bring that dx over, and then we can integrate both sides, okay? So the antiderivative of 1 dy, because dy by itself is really 1 times dy, is just going to be 1y. And then the antiderivative of 5 times the cosine of x, that's an easy one. That's going to be 5 times the sine of x, and then plus some constant value. And when we find, when we solve this and we have an initial condition, all we got to do is just find the c value, okay? So let's figure out what that's going to be. What this initial condition says is that when x, or t or whatever variable you're using, I guess we're using x, when x is equal to pi over 2, then the y value is going to be equal to 0. That's what this says, okay? So when I plug in pi halves for x, okay, so pi halves right there, I get the value 0 for y. So this allows me, if you can see, I have one variable that's unknown. That c value is the only thing that I don't know. So I got to solve for that. Sine of pi halves, that's 1. So this turns into just a 1. And 5 times 1 is just 5. So if I subtract 5 from both sides, I get my value for c is equal to -5. So just like that, I've got my particular solution for this differential equation right there. And those ones should be pretty easy for you. If you're struggling with them a little bit, just practice more, get some help. These should be your slam dunks, your really easy ones, your layups, okay? Next up, number 12, the rate of decay of a certain radioactive isotope of plutonium is given by that differential model, where m is measured in grams and t is measured in years. If the initial mass present is 50 grams, how much will be present in 30 years? This one, again, I don't know if your teachers are just going to allow you to say, oh, well, this is an exponential model, so I can just write it out as an exponential model, or if they make you like write it up or not, like solve it. I'm just going to err on the side of caution and just like solve it. But if they just allow you to write it as like the mass is going to be equal to the initial mass raised to the power of -1/20 times t, you can just write it up, but if they don't, I'll show you how to get to that point, like right now. If not, just fast forward through this if you don't need it, okay? All right, so dm dt is equal to -1/20 times m. And this is a separable equation, so I want to get all the m's on one side, so I'm going to divide by m on both sides. And then I got to get the dt over on this side if I want to integrate. Now it's just in terms of m on this side and t on this side, so I integrate both sides. The antiderivative of 1/m is the natural log of the absolute value of m. Antiderivative of -1/20 is going to be, dt is going to be -1/20 times t, and then plus some constant. And then we exponentiate both sides. So e to the power of natural log of m is just going to be natural log, or absolute value of m. And then the other one's going to be e to the -1/20 times t plus c. And then let's see. If the initial mass, so when t was equal to 0, the mass is equal to 50, then how much will be present after 30 years? So we can solve for the c value in this case. Well, okay, let's solve this a little bit further. So mass, first of all, is always going to be positive because you're never going to get like a negative mass. That'll be really weird. So just you can get rid of the absolute value just based off context. And then we did this like trick a little while ago where if we have an exponent, right, and it has different exponent powers, and we can combine them into one and add the exponents. Well, if I already have exponent powers that are adding, I can also go the other way and split it apart. And that's what I'm going to do here. So if I split this apart, here's what I end up with. Again, e to the negative 1 over 20 times t times e to the power of c. And c is just, e to the power of c is just another number. So I'm just going to call that a number, c1. And that allows me to say that the mass, when I use the time t, is equal to e to the negative 1 over 20 times t with some constant multiplying on it. So c1. Because I can just move that to the front if I want to. Okay, so there we go. Now I'm going to use this initial condition to solve. So if I plug in 0 for t, so the mass when time is 0 is equal to c1 e to the power of negative 1 over 20 times 0. And let's, and then I know the mass when t is equal to 0, it's 50, so that becomes a 50 there. And then let's see, 0 times negative 1 over 20 is just 0. E to the 0 is 1, and c times 1 is just c. So the constant is equal to 50. So c, in my little expression here, is 50. All right, so now I've got a model. So here's my model for the mass. And how much will be there after 30 years? So it looks like t is going to be in terms of years. So that means just plug in 30. So the mass after 30 years is going to be equal to 50 times e to the negative 1 over 20 times 30. And then it's going to be some decimal. Let's see what it's going to be using our calculator here. 50 e to the power of negative 1 over 20 times 30. What do we get? 11.156. Well, let's round it to 3 decimal places. 11.15, and then have another 5 after the 6. So let's say a 7 right there. And what were the units on this? It was rate of decay of radioactive, blah, 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 or mass is measured in grams. Okay, so it's going to be grams of plutonium. All right. Yep. All right, that's it. So that's also the end of the review. So I'll end this video. I hope you found it helpful. And I hope that you're pretty well prepared for this test, or you feel prepared. If not, definitely go, track down your calc teacher, get some help from them. I'm Mr. Cook. If you ever need help, please come by. I'm available after school. I'm available before school. I'll probably help you out during lunch too if you send me an email. But get some help, okay? Get some help through this. I think that's about it. Good luck on your test. Make sure your calculator is charged. That's it. I'll see you in the next video. Bye-bye. Did you stick around? I'm still here. I just want to say thank you again for watching the videos. I hope that they really are helping you. Calc's tough. You guys are near the end. I don't think you have like a couple more units to go. Stick with it. You can do this. Kick some butt. All right? All right, this is Mr. Cook. Peace out. Bye-bye.